Alright. Alright, so we keep moving on here. I want to talk about some common ions we're going to see quite a bit in earth science. The number one ion that we're going to see a lot of and talk a lot about is the silica or the silicate ion. And that's basically SiO4. SiO4 makes up the most common mineral, so it's a very abundant mineral source. In fact, its charge could be all over the place, but we typically would say, I think it's a -4. As its charge. So actually, it needs to bond with 4 other electrons in order to complete the bond. Okay? And that's why it's actually very abundant, because with that many slots that are open, it can actually create a lot of different compounds. So you can get aluminum silicates, you can get potassium silicates, so it readily bonds with a lot of different things, a lot of weird combinations. And we start getting into minerals. I know you guys kind of make fun of me because I like to, collect rocks and whatnot. But if you guys come over here at any time and you want to look at the minerals, take a look at that. Large variety of colors and crystalline structures is all dependent on this silicate, because it's every single time that you change that chemical composition, you're changing the color, you're changing the crystalline structure of the mineral itself. So you get all these beautiful formations, and that are unique formations. It's all because of this silicate ion. We also have carbonate ions. Those are usually going to be CO2s or even CO3s. A lot of times these are associated with ores. O-R-E. Okay, so the ores are basically where we get a lot of our natural resources. So a lot of the metals that we like to mine out of the earth come out of ores. Most of those are going to be carbonates. And then if they're not carbonates, then it's some kind of compound made with oxygen. Ferrous oxide is basically rust, but is actually a mineral. So any questions so far? Yes.
So, if you have CO2 compressed and CO3 compressed, which would be more powerful?
I have no idea. You guys go for it.
CO3.
I just don't think CO3 is actually a gas, though. So remember we talked about the 2 types of bonds. And this is really important for you guys to take note of today. This is actually a really big concept for today. Remember, when we bond, we're bonding through that outer electron. Okay? And sometimes we're sharing the electrons, sometimes we're transferring the electrons. So when we look at ionic versus covalent, your ionic compounds are basically when we are transferring that electron. A perfect example of that was the NaCl that we already saw, where sodium literally gave the electron to chlorine. That is an ionic bond. Anytime that that's being given away from one electron to the next. Most often, you're going to see ionic bonds between a metal and a nonmetal. And that's the biggest characteristic. When you're looking at a compound, you're like, okay, was that an ionic bond or a covalent bond? Easiest way to identify it, metal and non-metal, makes it ionic. So another example of an ionic bond would be a magnesium phosphate. And And I know those numbers are not fully correct, but it's just to throw it out there. So it's magnesium with PO4, and so basically what you have is a metal bonding with a non-metal compound. So that's going to be an ionic bond. And it's actually joining here with the PO4. Now, what happens when we have things that are non-metals? For example, when we look at things like H2O, definitely not a metal. Hydrogen is not a metal, oxygen is not a metal. And what about the next one there, C6H12O6? That should be important to you, that should be ringing a bell in your head that says, hey, I think I know what that is. Good job, DJ. What is it? Yeah, that's sugar. These are called covalent bonds. A covalent bond is basically when the electron is being shared. So if you're sharing the electron, that's going to be a covalent bond. Yes. And ultimately, it's when you have two nonmetals that are being bonded together. All right, that's all I have for you guys today. So I guess it's kind of a quick background on types of bonds. Yes.
How does cold building work?
How does what?
Cold building?
I had no idea.
Two metals in space and metals.
I had no idea. All right, so let's go ahead and end our show.